Hello and welcome to another special episode right here on the Total Space Network. On today's show, we're joined by Mission Director for the Polaris Dawn mission, Todd Ericson. As a proven business and military leader, Todd ensures safe and effective testing operations at the leading edge of commercial, human and satellite space launch operations. Thanks for joining us today, Todd. How are you doing today?
I'm doing very well, thanks. Great to be here.
No problem. First off, first question. Firstly, back during the events of Inspiration 4, how did it feel to have that good mission complete at the end of the St. Jude and everything?
It was amazing, right? Obviously, there's a lot of people that put in a tremendous amount of work that you don't see to make a mission like Inspiration 4 happen. And not only, to have the crew come back safely, accomplishing all of our objectives, but then I think equally as important to meet our fundraising goals for St. Jude, ensuring that we are not only exploring space, but that we were definitely bettering Earth back here while doing so was just a huge moment of joy. I think everybody was just so excited that everything came together.
Right, that was a great answer. Next, could you tell us a little about how you became Mission Director for Polaris Dawn and your journey there from being a Mission Director on Inspiration 4?
Right. So, obviously there was a lot of the Inspiration 4 team that has continued to transition, with Jared's vision of Polaris and the Polaris Program. And, obviously being part of Inspiration 4, there was a lot of background that is, very applicable to what we're trying to do on the Polaris missions. We were essentially trying to continue that vision that we started with Inspiration 4 of, continuing farther, pushing, space flight towards the moon, towards a return to Mars, but also ensuring that we, in doing so, that we better life back here on Earth. That vision is continuing with Polaris Dawn, and so it was kind of a natural transition to, take what we learned on Inspiration 4 and move most of the team onto the Polaris Dawn project.
It's quite a good idea of how Inspiration 4 actually led on to Polaris and how it's so similar but so different at the same time.
It is, right? So, on Inspiration 4, we can look at that as kind of the proof of concept, showing that 4 civilian trained astronauts could execute a mission. And, we went higher than, humankind has gone, probably at least really since the last Hubble servicing mission, well above the, altitude of the International Space Station. So, taking that kind of first step into our return to the moon and return to Mars. And, it was showing that was, something that we could do that was, you don't require a nation state to be able to go to space anymore, right? I mean, obviously we have, what SpaceX has done and what we were able to do through Inspiration 4 was built on a strong foundation of space flight, pioneered by NASA and others, right? So we certainly can't take credit for that building block, but, we were able to leverage that and show that, hey, we can do this in a different way, and it doesn't require a national space agency to do something.
Yeah, absolutely fantastic. Can you talk us through your average everyday at Polaris and with your work at Inspiration 4 as mission director and lead liaison with SpaceX and all things design, development and safe execution? What does your average day look like overlooking all that?
Right. Well, so what we're doing is basically keeping track of the program. We're in the phase right now where we have, defined the big picture objectives of Polaris Dawn. Obviously, we're going to go for an apogee higher than any Earth orbit has been before. So Gemini 11 was about 1,369 kilometers in the apogee. Polaris Dawn, we're looking to go over 1,400 kilometers. So we're going to set a record there. So there's a lot of things that go along with constructing that mission profile, and the other aspects of adding Starlink, laser-based basically connectivity to the spacecraft is a big one. And then obviously the first all-civilian EVA is a daunting task and a major objective of this mission. So, our job on the Polaris side, so I don't work for SpaceX. I work for, Jared and the Polaris Dawn team, but we are in complete cooperation and we're an intermeshed team trying to get these goals accomplished. So my day-to-day work is really kind of managing, where we're going. We need to be in agreement with SpaceX on, hey, what are the capabilities or the possibilities of the mission? What can we do mission design? How can we try to best achieve these objectives with the least risk possible? And it's a continued discussion, between the two of us as to, how to best accomplish these goals. So that's kind of where we're at right now. We're still in that mission design.
Yeah. So you're coming to them with, we want to do A, B, C. Can we do it? And you get feedback that way.
Yeah. I mean, it's a can we do it, and then it becomes a how do we do it? How do we accomplish it? And what's the most effective way? And basically, they're running obviously the lion's share of the engineering work and the mission design and so forth. And our job is just to make sure that we're in sync with them as to how these are gonna how things are gonna unfold, especially with a real eye towards the EVA, because that's going to be a significant piece of the mission. And obviously, Jared and the crew are going to be the ones executing whatever game plan we come up with during the mission planning.
How are you finding your previous experience with the US Air Force helping you in the day-to-day of basically working at Polaris?
Right. Well, so the experience I had in the Air Force is obviously very germane and very applicable to what we're doing. My last part of my Air Force career was all in experimental and developmental flight test, which is very similar to what we're doing here. You are trying to stretch the boundaries of what we currently know is possible. We're trying to go, higher, farther, faster, longer. Expand the envelope of human space flight, which is very analogous to how you do it, in the aviation or aerospace world. So that mindset, that mentality, how do you prudently analyze risk? How do you prudently accept risk? And how do you determine, whether something is worth pursuing or not are very applicable into this. And so that piece, along with my engineering background, helps me, at least liaise well and attempt to keep up with the extremely smart people at SpaceX as they're going through this.
Yeah, you often find that a lot of guys that have been in the military side of things, the space industry has a similar kind of way of working within reason kind of thing. So quite often, like we spoke to yourself, we spoke to Petit, similar kind of style of work, and it goes hand in hand. So it kind of, to a certain extent, prepares you for moving on to the space side after you've been in the Air Force, I imagine.
It does. There's a lot of similarities, right?
Yeah. And how did it feel watching the Invasion 4 team lift off the pad on the way to orbit?
Oh, it was amazing, right? I mean, we had talked long and hard about, when we wanted to launch and what time of day and everything. And, we really were just fortunate that the weather transpired to work well, but we really wanted that evening launch because I think there's nothing more spectacular than watching a rocket lift off, at night. It just changes kind of the local area from night to day. Kid and I were, fortunate enough to be in the firing room, which is, the control room closest to the launch pad, and just, being able to see everything light up, to hear it, to feel it. It's an experience that you just can't repeat on video, right? Being there is just amazing, and then I think more importantly, knowing that 4 friends were on board that made it extremely special.
Yeah, you must feel like a kid at Christmas when that launch director said go for launch.
I would say, at least for me, it's a lot like playing sports. I remember, I played American football, so but it's the same as any big sporting game. As the game is starting to proceed towards start, you've got butterflies. You're thinking about a lot of different things. But then once the countdown started and once things got going, you flip into your mode of, okay, it's time to do this, do what we've trained to do, and but there is such a huge, I guess it was just a relief, or relief is probably not the right word, but it just an amazement when we actually saw it actually launch. All that we had been training to do was finally taking place, and it was just it was awe-inspiring.
Fantastic. And speaking of lifting off into orbit, if the day came that you could get a return trip to Mars on Starship, would you take the opportunity?
Oh, of course. I mean, I can't. I don't know of many people who love space and exploration who wouldn't take a chance at that. It's going to be quite an endeavor going to Mars and back. Right now, it's at least a year and a half time commitment and travel both ways. And then whatever you do while you're there.
I think the moon will be a bit more closer to home, a shorter trip.
It will. Certainly not for the faint of heart, but what an amazing opportunity that would be.
When it comes to training Anna and Sarah, do you still use the same scenarios that you trained the Inspiration 4 crew with, or do you totally mix it up to surprise them, as they've already gone through most of the training scenarios while training crew? Right.
I mean, that is one of the wonderful things about this mission, is that Anna and Sarah are such the experts on Falcon and Dragon. It's an amazing blessing to have them as part of it. So, I mean, there are obviously, and then obviously Jared has gone through all of the training with Inspiration 4. Kid, as a mission director, was part of all that. So everybody is starting with just this tremendous baseline of experience on Dragon and Falcon. So there will be certainly some required refresher and required training along those lines. With Sarah and Anna in particular, it's one thing when you are the mission director or on the the ground support side of the house, and now you're transitioning to actually being in the vehicle itself. So there's a little bit of change there. But what the training on this mission is going to focus on is really the things that are really unique to this mission. Obviously, the orbit itself, a high inclination or a highly elliptical orbit is something new and different, and there's some challenges associated with that. The EVA, of course, is a big thing that's going to be focusing a lot of time. We went a couple weeks ago and started some of our training by doing some scuba diving out at Catalina Island, to try to get into that analog, kind of Earth-based analog for what they're going to be doing. So there's more to follow on that kind of training. So a lot of the stuff that's going to be going forward, is going to be really mission-specific type training, if that makes sense.
Yeah, and in our interview with Kid, where we asked about the initial orbit profile, as you mentioned just there, of the Polaris Dawn mission, he suggested you'll be able to give us more detail on the answer on the aspect of this mission. So he initially, highly elliptical phase is the plan to complete multiple orbits around the Earth, especially since the Dragon capsule is passing through the Van Allen belt at this stage. Will it be multiple orbits over a few days, or will it just be a couple of laps around and then come back down?
You bet. We're still, we haven't finalized the orbit yet, but roughly speaking, we're looking at a orbit with a perigee of about 200 kilometers. Kind of typical Falcon insertion orbit, and then boosting to an apogee of at least 1,400 kilometers. We're planning to do that for at least a couple orbits, so it's not going to be just one orbit and be done. We're going to do a couple. And then kind of the mission right now is trying to understand where we want to do the cruise orbit. If that's going to be in that 600 to 700 kilometer apogee, we'll still keep a 200 kilometer perigee, so it'll still be an elliptical orbit. But trying to understand where it's best going to be for cruise for the mission duration. But it's probably going to be, roughly speaking, somewhere around the 700 kilometer apogee. The Van Allen belt that you described is obviously a consideration. We're going to be going up and into that at 1,400 kilometers. What is more of a mission consideration is really the South Atlantic anomaly. So, that is an area where, the radiation belts are lower in altitude. So we're trying to be very mindful of how we transit through that in the mission profile. So that's driving a lot of that design. The good news, though, is the highly elliptical nature of the orbit means that you're not dwelling there for the entire orbit. You are up into those areas for a limited amount of time, and radiation wise, right now there are no showstoppers or no real concerns about radiation dosage.
Right, following on from this, how does SpaceX set a limit to how high Crew Dragon can go, and could any technology be added to get Dragon into lunar orbit?
Oh, that's a good question. As you guys know, Dragon was initially designed from the onset to basically go to the ISS, which is at about a 420 kilometer orbit, right? And so that was kind of the initial design point, and most of the systems and everything associated were designed around that mission. Inspiration 4, we expanded that, obviously, going up to almost 600 kilometers of orbit, and that that causes other concerns and issues. The higher you go, radiation becomes more of an issue, and it's not just radiation for the crew, but it's radiation for the electronics. There are the Dragon capsule is electronics are designed to be resilient to a lot of those and redundant, but that is a consideration that you have to have. The other piece is reentry, right? So if there is some sort of anomaly, can I now reenter safely and quickly within an acceptable amount of time from that altitude? And so it goes back to, okay, hey, this is what we've got, this is what we've designed, what can we do differently to achieve these goals? And the same is happening on Polaris Dawn. One of the concerns is, okay, if we do have a problem while we are in that highly elliptical 14 by 100 by 200 kilometer orbit, how do we ensure that we can safely get the crew back down and recover them expeditiously? There's a lot more energy that you've got to dissipate coming back from 1,400 kilometers as opposed to 420. So working through some of those technical problems has been really interesting. But the engineers at SpaceX are amazing, and it's been truly wonderful watching how they can take something that was designed for a 420 kilometer altitude and expand that envelope. In terms of getting back to the moon or doing a lunar mission with Dragon, that becomes more difficult. Life support once again for Dragon was designed to sustain the crew for up to about 5 days is kind of where we're at. So a lunar mission would be a lot more. So trying to expand it out to something like that, you not only have to have a bigger booster than Falcon 9, but also do some significant changes to the architecture, and that's really why SpaceX is going towards Starship for the lunar.
Going up on the radiation and everything to do with that, it was once the capsule's back and landed in the ocean, as we've seen with previous missions. Will there be any further safety precautions or checkouts once the vehicle's in the water, or will it be within reason, within the same limitations once it comes back through the atmosphere and splashes down?
Yeah, there should not be any real significant differences in the recovery on Polaris Dawn by any of the other human missions on Dragon.
Of the experiments that are being considered to be performed during the Polaris Dawn mission, is there one of them that's your favourite or one you'd like to tell people to look out for?
Oh, man. So I think one of the things that we're going to do that I think is very exciting. Well, there's a few things, right? There's the scientific pieces, and then there's the inspirational pieces, right? We're partnering with Embry-Riddle University to put up a high definition camera up in orbit with us, which I think from just a wow factor of bringing people up into orbit with us and inspiring people to see what spaceflight is like, and most specifically the EVA that we're going to be doing, having that captured in high definition with this latest generation of cameras is just going to be amazing.
Yeah, just looking back at the blue marble floating in space and maybe the capsule.
Yeah, and I'm personally a fan of I think it's amazing to look at Earth, and that's really important. But I think, at least my focus would be out towards the deepest space, where we have to go yet. I think, that is going to be an amazing view as well, and just being able to bring people along with that. So I think from an inspirational standpoint, that's going to be amazing. We're doing some radiation experiments with the Pacific Northwest National Laboratories, kind of better understanding, what is the radiation exposure, what is the radiation risk on a couple different levels. So they've got a unique experiment. Not something overly exciting, but I think it's extremely important. But the one I think that people should really concentrate on is kind of some of the stuff we're doing with space medicine, because that really folds well into the mission of Polaris, right? Polaris Dawn and the Polaris missions are continuing that vision Jared set about, hey, if we're going to go explore space, we got to do better back here on Earth. And we're trying to expand accessibility of medical care and connectivity beyond just the U.S. If you talk to St. Jude right now, the number one determinant in whether someone survives childhood cancer is really where they're born, right? So, and through some of the things that we're doing, we're pioneering space-based Starlink, right, for connectivity. That same connectivity is going to allow us to now reach anywhere in the world and provide the same level of care, the same level of diagnosis for some of these diseases as you would, being in London or being in Chicago.
Yeah, that technology just opens so many doors, with even out in rural parts of America, even if they're not by a major town.
Absolutely. And, some of the unique things, we've got this handheld ultrasound machine that basically uses it on the iPhone, that you can now, present images to an expert that's not necessarily co-located with you. I think that piece is really exciting, and I think will be fundamentally changing towards, life back here on Earth. And I'm really excited about that piece of it.
Fantastic. And from your time at Inspiration 4 to your time with Polaris Program, what has been your proudest moment, or perhaps what would be your proudest moment to come in the near future?
Oh, man. From Inspiration 4, right? Obviously, launching and returning the crew is huge, but I think collectively, the proudest moment, I think, for all of us was, the crew was back down and safe. There were a few of us that were leaving mission control in Hawthorne to join everybody in Florida. We got on the airplane to start, heading back to Florida. And right before we took off, we got word that we had just broken our fundraising goal for St. Jude's. Right. And so I think for all of us, that was just, putting the whole picture together, that, hey, we had done something and we had been part of something that was fundamentally a milestone in human spaceflight. But more importantly, we had done it, and and this is testament to Jared's vision, that we had done it in the right way. It wasn't a self-serving thing. Obviously, it was very exciting and very cool for them to go do that mission. They took it to the next level and ensured that they were making a huge difference back here on Earth. And that was kind of the proudest moment, because the vision had all come together at that point. The crew was safe. We had made the fundraising goals, and that was truly a mission complete kind of experience.
Yeah, it was just absolutely incredible, the amount raised. I can't remember the number, forgive me, off the top of my head, but it was just phenomenal.
It was right around $250 million, so $250 million, for the cause, which was amazing.
Yeah, absolutely incredible. And just going back to your career and everything, have you always been fascinated by space, or is it just something that's developed over time with your time in the Air Force?
I'd be lying to you if I said I always wanted to go to space, right? I think a lot of people say that, but I don't know that that's actually true. For me, I grew up in an aviation household. My dad was an airline pilot. I learned to fly. I was fascinated by aviation. Went into the military and, flying fighters and all that. But as that developed, I think it was more that I finally realized that there was a possibility of being involved in space, that space was more real than, I had given it credit for before. So over time, that desire and that passion for space, I think has just kind of really developed, is probably the best way to put it for me.
Yeah. I mean, for me, it was NASA curiosity, like the Mars first Mars rovers were quite a number of years ago now. When I saw that land on Mars, that was just absolutely incredible for me. Thinking back to when you were younger, what was the one thing that always sticks in your mind about space? Was it some of the Apollo missions? Was it or something else about that?
No, I mean, I was literally 6 months old when Neil Armstrong landed on the moon, right? So the Apollo missions were honestly too early for me to really remember, other than through pictures my parents took and so forth. For me, the space shuttle was kind of that defining moment. I remember my dad and I took one trip. We lived in Chicago at the time. We took a trip down to the Cape to go watch a shuttle launch. Unfortunately, it had a long hold, I think it was around T-minus 31 seconds or something like that, and we couldn't stay for the launch. But that was kind of captivating, right? It was, the adventure of that, and then obviously Challenger and Columbia were seminal moments. But it, highlighting the difficulty of space, but also recognizing that, hey, this is, things that are important are worthwhile pursuing despite of setbacks. Some of the Hubble stuff, I remember the Hubble, which was amazing to me, to be able to, see that launch. I remember the disappointment when it wasn't quite, working right initially, and then just the exuberance and how cool it was that we could fix something in space, and then, all the science that has opened up. The challenge of space, things that are worthwhile are difficult, and there is so much we have to learn going forward. So that's kind of what's really kindled my passion, I guess, for spaceflight.
Number 13, any thoughts on the Starlink Laser-comm?
Oh, the Starlink Laser-comm. Yeah, I think that is going to be an amazing part of this mission, right? Up until this point, we've been very reliant on the TDRS network for data and communications in space. This now allows us to kind of take it into the 21st century, right? We are now going to be able to use laser-based comms, so you're basically able to pass a lot higher bandwidth data back and forth. It's going to be more redundant. You are now using what's going to be a network of 30,000 satellites, if you can believe that, in the Starlink network, it's just going to be able to improve that kind of capability. But the great analogy is, hey, what we're doing in space is directly applicable, to life on Earth. I mean, it is as isolated in the middle of Africa as it is in outer space in terms of communication, and being able to pull that together. I mean, that is, talk about shrinking the globe and allowing somebody in any part of the world access to the same education, to the same healthcare, to the same capabilities and opportunities that anybody else in the world has access to, I think is going to be revolutionary.
Is there any chance of a little surprise in orbit while the guys are up there, while they're testing the limitations of that?
Well, we're working on some of that. I mean, obviously, we would love to be able to bring, high data rates, video and, imagery and those kind of things, to show you something that you haven't seen before. That's all going to be dependent on a lot of things and details that we're working out yet. So this is obviously the first step. I guess stand by for more on that.
Whilst we understand that the Polaris mission feed into and inform the next sequence, can you tell us if there's any details being hashed out currently for the mission 3 with Starship?
So the big picture with Starship, right, is it's going to be the first human flight of Starship, right? So, that is going to be the primary mission objective is, hey, demonstrating that Starship is habitable, that we can safely bring humans up and back from space and do things on orbit. So that being said, right now there's so much Starship development that's going on. It's really, beyond those broad strokes. We haven't had a lot of definition on that mission yet, and that's gonna. That will kind of come into focus the closer we get to it. Really the intent is, okay, what do we need to demonstrate? How do we continue to advance the bar towards getting back to the moon and getting back to Mars? So really, long story short, is the test flights up to that, to the point that we actually do Polaris 3 with Starship is going to be informative as to what we actually do and what we're capable of doing on that mission. The idea will be to continue to expand the envelope as we have on all these others, because, going up there is a significant cost. It's not an insignificant risk, and you need to make sure that you're doing something worthwhile while you're doing it. So.
Well, actually good, right? Okay. Right. So previously talked about another Netflix.
Yeah. We are certainly going to document this endeavor. Whether it ends up being on Netflix or something else, is yet to be seen. But we are certainly documenting the journey because it is historical and it's a big deal. We were just down in Ecuador climbing a couple volcanoes, and we did have a crew along with us because that's an important part of the journey and a part of the training. As Jared would say, it's important in spaceflight that those going are comfortable with being uncomfortable and pushing limits, going further than you thought you could, because space flight is not easy. And so so long story short, we did have a crew with us documenting that. There will be something. What form it ends up taking after the missions is yet to be determined, but definitely we understand the historical significance of these missions and are going to make sure that they're certainly well documented.
Brilliant. I know you vaguely already answered this one, but can you tell us anything from the technical aspect of things, how involved Polaris is in the research and development of Dragon and Starship?
So Polaris, we are partners with SpaceX. Obviously, SpaceX owns Dragon and Starship. They are very receptive to our input, and it is a partnership going forward with how to make these missions happen. So we're very involved from that standpoint. Obviously, they own the technical aspect of it and the engineering piece. We're the ones who are asking, hey, is this possible? Is this possible? And they're going, yeah, we can do that, but it's going to take this much work, But I've been absolutely impressed and amazed with the capabilities of those engineers and what they've been able to accomplish. It's truly a testament to giving the right people the freedom to work and come up with great solutions, and they do surprise you in a positive way. And SpaceX keeps doing that. It's really impressive.
Yeah, it seems like a brilliant work environment that they've got going there, and you can literally. The Polaris team can come up with a whole host of suggestions, and the team will come back to you to say, yes, no, it's not possible, but they'll probably come back with a load of suggestions. I mean, you've been there, you've been on the table talking to them anyway, but I imagine it's probably a different situation. Everything must be really good.
Well, and what's even more amazing than that is that they'll come back and say, hey, you know what? We could even do this. A great example was the cupola on Inspiration 4. That was nothing that we asked for. That was nothing that was part of the original plan, but it was a bunch of SpaceX engineers saying, hey, we have this opportunity. We can make this happen. And to go from literally a concept in November to flight hardware on orbit in September for something like that is just absolutely amazing and kind of testament to some of the stuff that they do.
Yeah, just like breakneck speed development and everything. It's just absolutely incredible the speed they're doing everything in at the moment. But for the Polaris Dawn mission specifically, what are you looking forward to the most? And also on the flip side to that, what are you looking forward to personally?
Yeah. So I mean, once again, it's an emotional event when your friends are getting launched into space, right? So I'm so looking forward to, kind of hearing from them when they get back as to, what it was like, what it was to be there in person, to see the Earth from 1,400 kilometers, to be able to, what was it like to be alone in your spacesuit, as your own satellite of the Earth, and just what freedom that feels like. I'm just really excited to hear that feedback, and then obviously we're equally excited to see what good we can do back here on Earth, and how we are able to advance that bar, because that is as if not more important than what we're doing on orbit for sure.
Does Polaris or even Inspiration 4 ever had a backup?
A backup crew? Yeah, we had discussed that on several occasions. The logistics involved are just difficult because the training is very specific for each mission. So right now we are not going with a backup crew at all on the mission. So because each person is going to be so specifically trained in their aspect of the mission that trying to get somebody, you'd have to train that person for all four positions if they were really going to be a backup, and that just becomes logistically a pretty difficult bridge to cross.
And last question before we go, Leif. If you'd like to take this time to say anything to your colleagues back at Polaris HQ who might be watching this, what might it be?
Oh, it goes without saying. I mean, they know this as much as I do, but it is, just an amazing adventure and such a privilege to be part of, I think, something that is just, it's a seminal event in human history. What is being accomplished in the in spaceflight today, we are currently in the same place in space as we were between World War I and World War II with the aviation industry, right? We're taking this thing that was really the domain of nation states, that only countries could accomplish, and only a few countries at that. And now we're bringing it into the realm where it is possible for everyday humans to accomplish. And what that is going to enable and how that's going to change life here on Earth is yet to be seen, but it's going to be absolutely amazing, right? I think right now we can't think and can't comprehend of all the repercussions, that will come about of this, right? So, I mean, take your cell phone, right? The cell phone was designed for communication. Well, look at how reliant we are on that for so many other things that at the time we could never think of, those possibilities. So, so being able to be a part of something that is, going to be fundamentally changing to life as we know it is huge. There are so few times that you can look back and know that you are part of something that is going to be game-changing worldwide, and so I think we're so privileged to be part of that. But more importantly, to be able to do this with a team of men and women that you love and you respect and you have fun with. It is truly a blessing beyond belief to be able to do that. So I'm just excited not only to do this, but also equally excited about the journey because it's so much fun working with all these people. So.
Absolutely brilliant. Right, thanks for your time today, Todd. It's been absolutely incredible speaking with you. And if anyone wants to find out more about the program, head over to polarisprogram.com. Their work with Jude and so much more incredible work they're doing. Thanks for joining us again, Todd.
Thank you. It's a pleasure being here, and thanks for taking the time to have me on. I really appreciate it.
And we lost. Yeah, I think one of our team members needs Starlink laser communication at this moment in time.
There you go.
Poor Jack there, popping in and out.